Okay. So we did the power rule. I showed you the long way to find a derivative using the limit, and then we did the power rules, and then I gave you some of the trig derivatives. So now we're going to do product rule, which basically lets you do a derivative of two things being multiplied together. Sometimes you can multiply stuff out and do it term by term, but most of the time it's best to just use the rule. Because multiplying can get ugly if you have like huge powers. So this is the power rule. So let's say y of x is equal to two functions being multiplied. The derivative of y, well, let's use the quote notation. So the derivative of two functions multiplied together is going to be the derivative of the first function times the first, or times the second, plus the derivative of the second function times the first function.
That seems familiar.
Yeah, I'm pretty sure you've seen it before. I'm going to go ahead and give you the quotient rule as well. I like to give them ahead of time before we start. Any question?
Nope.
Okay, quotient rule. Let me double check the formula because I always forget where the minus goes. And I don't like giving big formulas out. Okay. So if your derivative, if your function is equal to f of x divided by g of x, and of course g is not equal to 0, then your derivative will be derivative of the first one times g minus f times, oops, actually, I'm going to try to write the same way I wrote the other one. Minus the derivative of second times the first. Double check everything. Yes. So I believe it's the same thing. Yeah, there we go. Divided by the g function squared. So whatever that is, squared. So if you have a function divided by another function, some sort of fraction type, you'll have using this will be your best bet. Sometimes you can force it into a product rule, but it's rarely worth it because you get some ugly. Yeah, you might have to do some extra algebra, depending. Okay.
Okay.
All right, so make sure you have these formulas on your note card or formula sheet. They're also on the sheet that I sent you.
Awesome.
Example 1. This is problem 1 from the homework. Fine, I'm going to label these as y of x, just to keep the same look as your formula, as the formulas here. So y of x is equal to x squared plus 3 times x squared minus 8x. So we have a product, so we have to do product rule. To treat this like your f function and your g function. Now the formula, if you look at it, it needs an f prime and a g prime, right? So label right here what f is, just on the side. f will be x squared plus 3. So what is my f prime?
It's going to be 2x.
Yeah, just 2x, right?
Yeah.
Now, if g is x squared minus 8x, what is g prime?
It is 2x minus 8.
Yeah, 2x minus 8. So now that means that the derivative will be equal to f prime of x times g plus g prime of x times f. So f prime goes right there. G goes right there. Plus g prime times f. So far, does that make sense?
Yes. This is coming back now.
So now just multiply it out and you're good. At this point, the calculus step is done. So just distribute. Double check there. Yeah. Okay, so there's the distribution. Now combining like terms, we have a 2 and a 2 cubed. So 4x cubed. Negative 16 minus 8 minus 24x squared plus 6x minus 24.
And once you've got it all in the right order and everything, you're done, right?
Yeah, at this point, if there's no more terms to combine, then that's it. But yeah, that's the product rule. You got any questions about the steps or the formula?
Nope. Once I knew the formula, it's pretty easy.
Yeah, it's not too bad, right?
No, I was trying to do that one 3.3 and I forgot what the formula for it was.
Oh, I see.
Yeah, it got a little rough.
Well, that's okay. I mean, it's better to try it out right before just to see what you're dealing with, you know?
Yeah.
That's what all my professors used to recommend. Try out the examples first before you get here. All right, let's do number 2. Just a moment. Okay. Cool on the first page.
Yep. Good.
All right, so example 2. I'm just going to shorten it up, find dy dx. So this time I'll use the other notation, just so you get used to it. Y of x is equal to 3e to the x cosine x. But this is my, call it f and g. Now you don't really have to include the 3, but might as well. Okay, so a little space here. So if my f is 3e to the x, what is df dy? Sorry, dx.
Because E is weird. E is just itself.
Yeah, pretty much. The
So
3 doesn't do anything. So just itself.
okay.
So g is cosine. So this one you have to have either memorized or you need to have your formula sheet out. Do you know the derivative of cosine?
Negative sign? Or no, it's regular sign and sine is negative cosine.
No, I had it right the first time.
Okay.
So the opposite of what you just said.
I know one of them has the negative other and the other one doesn't.
Yeah, you're right. So now I want to find dy dx. So using the other notation, it's going to be df dx times g of x plus dg dx times f of x. I didn't put the f of x here and g of x there, but it's fine. It's not wrong. It's just I'm calling it the f function and g function instead of f of x. That cool?
Yep.
It's actually more proper, but this book or early calculus doesn't write it that way. Anyway, derivative, the original, plus derivative of g times f. So the final answer will be, I think they factor the common 3e3x or 3 times e to the x. So we can go ahead and do that. If you factor 3ex from both terms, you'll get cosine minus sine.
Awesome.
Any issues with example 2?
So we were looking for dy dx. So how did we know which because this was 2 separate fractions, right? To start off with.
We had
The
it was 2 functions, right? 3ex and
yeah.
cosine. So
Oh, okay. So they weren't they weren't fractions.
no, we're just using the Leibniz notation.
Okay. Yeah, that underline and then the f of x and g of x threw me off a little bit.
Yeah, so this is derivative of f with respect to x, which is right there.
Yep. Yep, I get okay. That makes everything a lot less confusing.
Yeah, I'm just I need to make sure I use it once in a while so it doesn't mess with you when you see it out in the wild, you know.
Yeah. Well, no, it was the y of x equals. It made me think they were fractions.
Oh, this guy
No, up
here.
on the left, like right below where it says example 2. Yeah.
Oh, I see what you're saying.
Yeah. So I
Yeah,
was kind of confused. I'm like, how do we know what f of x was?
I see. Maybe I'll just draw an arrow instead.
Okay. But now I get it. It just threw me off.
No, it did look like fractions. You're right. Okay. Anyway, so this product rule makes sense. So we can move on to quotient rule, or we can do more of these types.
We can go on to quotient. This makes total sense
Okay.
because it's just a plug and chug, pretty much.
Yeah, I advise making a little side table just
Yeah.
to keep yourself straight. You don't have to do that, but
No, I do it. I do it on all my stuff.
cool.
That way, if I like mess up halfway through, I know why. And I don't have to start all the way over.
True. True. All right, let me turn the page then and let's do a couple of quotient. The weird one is the chain rule. That one's always hard to wrap your mind around, but also um, teach.
Oh my god.
But that's
No,
three.
I think
That's
I was good with chain rule. Yeah, I was good with chain rule.
oh, that's good.
That
That's
was
three.
actually one of the things I was better at.
It was
Which is
3.4, so we're not there yet. But I always felt like that one was hard to explain to people.
yeah, definitely. It's like a turducken.
Yeah, yeah, I guess so. I've never eaten one, but I
I haven't
think
either.
I think you're right. Sounds like a monstrosity.
Right? But chain rule, chain rule I know.
The turducken.
Well, like, chain rule wasn't that hard for me because it's just it was like the orders of like g of x is an f of x, then you did
Hmm.
yeah.
Yeah, that's true.
So it just showed you like what went in where, and then you solved. So that's one of those like I think like, as soon as you know how to like read it, it's
Hmm.
pretty easy to do, but I can get where it's hard to read it.
Well, I mean, you are pretty sharp, so it's not necessarily fair.
I don't know. Some of the stuff throws me for a loop sometimes.
Okay,
I never had test anxiety when I started college.
that's funny.
Didn't know what it was. I thought people were making it up.
Yeah, what are you guys talking about? Who cares? I guess things just become more real, more serious. Maybe that's
Right? It's
what
like
it
suddenly
is.
you're paying money for it.
That too. Good point.
Definitely adds an air of desperation.
Yes, especially if you're like a expensive private college or university. Like, man, I would hate to start over. That'll just be 8 grand. It's cool.
Right? It's like, well, you went down past the 3.5, so we're revoking your scholarship.
Oh man, imagine like if you're like MIT or something.
Ugh.
Let's mess something up.
I don't think I could be there just because of the people that go there.
Well, what how so? Or I'm not as familiar, I guess.
Oh, they're just all those little Ivy League kids are so snotty. And that's like all they talk about for the rest of their life. It's like what Ivy League college you went to.
I guess I could see
Like,
that.
okay, Derek, we get it. You're 82, so shut up.
Hmm.
They're annoying. And then they're entitled too. Because I don't know, a lot of people like I work for who do that were usually not there on scholarship.
Well, I mean, I
Um,
think
the one
I
person
think what you're describing is just rich people.
yeah. But I don't
You
know, because I knew two other people that like went there on scholarship and one of them just ended up being like really entitled because of it. But I mean, it makes sense. Like anyone from a lower place in life, as soon as they get a taste of richer stuff, is gonna go a little nuts.
I guess, but I don't know. I mean, I was born pretty poor, and I'm not anymore. I feel like you shouldn't look down on that stuff, or become classist. I
Yeah,
guess
that still happen.
it's a shame that they do that. We forget
Don't
where they
get
came
me
from.
started. I hate all this like, oh, I worked myself up. Yeah, it's like I work myself up from the bottom, so everyone else has to do it too. And I'm gonna take away all the resources I used.
Yeah,
Freaking Greg Abbott.
some bullshit right there.
Yeah.
Oh man, Greg. You say Greg Abbott?
Yeah. Because like he still gets money from his lawsuit that made him end up in a wheelchair. But
Oh
no one else can get that kind of money from it because he stopped that.
yeah, I think I remember reading about that. It's such BS. Yeah, I don't know why. I don't know how he won so many times. He has yet to
No,
fix
you think they would
anything.
have. Yeah, I was hoping this last election with everything that went on like right before it, but nope. At least it was a little narrower this time.
Yeah, it seems to be narrower and narrower.
So maybe in like 10 years we can hope.
I don't know how people could keep voting for fucking Ted Cruz. That guy sucks.
Oh my God, and everyone knows he sucks too. Like no one who votes for Ted Cruz even like approves of Ted Cruz.
I know I've talked to like conservative people and they're like, yeah, well, we don't like him either, but he's on our team. I'm like, okay, whatever, man.
Yeah.
It's like I feel like you vote for anything that has R on their name. It's like,
They literally did. There was a case in I think 1990 where there was a name up on the ballots and it was I don't remember what it was, but had the R by the name, was the only Republican candidate. Well, it won and it was a donkey. No one looked him up. They just voted for the R.
yeah, I don't like this two-party system nonsense.
No, that's stupid. It's like one of the one good things George Washington said was don't form a two-party system. And 10 years later,
Yeah, it's a shame. Anyway, all right. So here is the quotient rule. So numerator is f, denominator is g. Derivative of f is just going to be a 1, right? And what is the derivative of g?
yeah, it's gonna be 4x cubed, and that's it.
And that's it. Just plug it into the formula right here. df is a 1. G dg dx over g squared.
So it ends up being like 3x plus 7. Negative, no, negative 3x plus 7
Yeah, that
on
sounds
top.
right.
It's gonna be a 3x to the fourth power, right?
On the bottom?
No, on the top. Because
Oh,
4x
yeah.
cubed and x multiply, and then we already have x to
Oh, shoot.
the
So this became 4. Yeah, you're right.
yeah, and then they have the same power, so they could be subtracted.
Mm-hmm. Okay. And they just leave it this way on the homework.
Awesome.
Okay. Yeah, I thought he was going to lose after the handling of the pandemic and the freeze and no improvement.
Yeah, especially the freeze.
mean, it hasn't done any improvements or
You've made it actively worse because all the systems are falling into disrepair and not being fixed.
yeah.
And we need to join the US power grid. We shouldn't have our own power grid. It's stupid and it sucks.
Yeah, I mean, if they're not going to do anything with it properly, they should stop being stupid.
Well, and like the thing is too, is like we can provide still a lot of our own power, but that would allow us to, in emergencies like what we had, receive power.
Hmm.
But they're like, oh, we'd have to have rolling blackouts on occasion. I'm like, yeah, but that's better than just full weeks long blackouts.
Yeah. Yeah, it's just nonsense. Need my freedom.
Oh my God. The freedom to like die frozen.
Yep. Oh man. Now just do one more quotient and then we'll move on to something else.
Okay.
Yeah, I think he didn't he spend like I don't know how many billions on his nonsense at the border, like checking trucks or whatever. Do you remember that?
Honestly. And nothing, yeah, and that doesn't even matter because the majority of, and I don't really care about it, but the people that do are like, oh, it's the border, it's the border. No, the majority of immigrants come in through planes and they just don't leave.
Oh
And I'm
yeah.
like,
I mean that's a
and you're
good
not
point as
gonna be,
well. But I was
yeah,
just
like you're
talking
not
about
gonna be able
the
to stop them really from that way. That's just how it is. But so all the money on the border is being kind of wasted because that's not the majority at all, and even that isn't really stopping much, and I don't think it should be stopped in the first place.
yeah, I mean
Not when
that's a whole nother area that he's wasting money on, but the one I was mentioning was when he was stopping the trucks to check for immigrants and drugs and he found nothing. He spent like I think he wasted like billions and on this stupid
yeah,
endeavor. That
yeah,
was
that's the thing. Like, so few are gonna actually come through, the checkpoints and everything because they know how cracked down the border is. They're just gonna fly in.
yeah.
And like you can't really stop them. Like they fly in, okay, like they're visiting and they just don't come back for another flight.
Honestly, I think they're immigrants is what's gonna save our growth because population growth is plummeting in every country in the world except ours because of immigration.
Yeah.
It's just
And we need, and look, yeah, and they deserve to come here too because all of them that I know of are from countries the US has destabilized itself.
I don't know.
Destabilized.
That shit's so messed up.
Especially like I'm pretty sure it's like all of South America at this point, South and Central.
Mm-hmm. It's true.
So it's like, yeah, we owe them.
Yeah, good luck
Yeah, I don't
getting
think
them
the
to
US
pay.
can like afford to be neutral.
Yeah, it'd be nice to see them actually pay them back, but good luck seeing that happen.
Right.
Oh man. Okay. But yeah, I think the problem is people just don't vote here. I don't know what's up with that.
Yeah. I don't think a lot of them know too. I mean, they obviously don't know because they don't care and they don't seek out that information. But some of this stuff just isn't like pushed into people's faces as much as everything else is.
True. There's a lot of people. I mean, yeah, I guess I was one of them too growing up as a kid. Like politics was not anything we've ever talked about growing up. If anything, my parents kind of discouraged it, like voting and whatnot, just out of pure ignorance.
Yeah.
Um, so yeah, I think it's like a cultural problem, just uneducated problem. But yeah, like even people that are not that are born here, um, don't even know what the hell's going on. Which is weird. It's
Yeah.
weird.
Well, the Republicans try their best to keep it that way.
True. And
There's a reason they're, and I hate to say effective, but it's what they are in debate. It's because they don't feel the need to prove their things are true. Um, and they don't really give time for other people to poke holes in them because they just, what was it called? Idea bombing,
mhm.
where they just say so many things within so many seconds and your mind can't keep up and question all of them.
Yeah, yeah. That's it's one of their debate techniques. That's what Ted Cruz uses, and a lot of the Jim Jordan does the same shit.
Alex Jones. Yeah, Alex Jones was the big one. And I don't know
Except
his name,
Jones
but
spits out complete nonsense.
yeah. But it worked for some reason.
I don't know. I talked to some people about that. I'm like, why do you guys, listen to this guy? Don't you think he's dangerous? And they would just laugh and say, no, he's just funny. But I'm like, now, after what happened, I'm like, I don't think it was. I think I was right. He was always dangerous.
Yeah. Because like they start off and it's like, oh, it's funny, but then that stuff just slowly kind of accumulates in their head.
Yeah. I'm like, I don't think he's a comedian, dude. Like, I think he's just a crazy person.
Yeah.
Anyway, all right. So three sine derivative. What's that gonna be? I'll do the
With
hard
the M and the S, I don't know.
with the three.
Yeah.
Oh, remember that you can always take the derivative of the function and disregard the number, the constants.
And it's just going to be 35.
It's three sine.
Oh, I thought it was an M. I thought it was 35 MX.
Oh, yeah. I guess I wrote
I got a little confused.
it.
It's just my I had to switch over to my phone because this poor shitty little laptop I have like crapped out with memory.
Oh, that's okay.
So that's why I had to like rejoin the I had to rejoin the Zoom so many times. So it's just kind of small on my screen, so it was hard to see. So yeah, okay, yeah, 3 cosine x,
There you go.
absolutely.
Yeah, it's 35 mx. Yeah, that's right. All right.
My s's are the same way. They look like my fives and my s's are the same.
Yeah, I don't like the writing the number five, man. Can't do it.
No, it's so angular.
Yeah.
Just a lot of work.
Okay. F. There it is. Okay, so this will become 3 ex cosine minus 3 ex sine over ex squared. So at this point, we could factor 3 ex and cancel one of these, right?
Yep.
Oops, the three's still there.
Yep. That's good.
That should be it. Okay. All right, let me show you the last few questions. I don't think it's worth doing, but just wanted to show you. Can you see the homework?
Yes.
So after the first few, doing product and quotient rule, they're going to tell you plug in C into your derivative. So you find f prime, you plug that in here, and then you plug in the number they're talking about. 0, well, that zeroes all these out except that part. Same thing with this guy, you do your quotient rule, and then you plug in the C, you get some number. That's about it.
Yeah, it's familiar.
But yeah, nothing crazy. Just one extra step after you find derivative. Now, these are similar to what we did last time. Remember how we said find the equation of the tangent line?
Yes.
The only difference is your derivative is going to be a quotient. So before we would do a basic power rule and plug in the number to find the slope, the m tangent. This time you will use the quotient rule.
Okay.
So same thing as before, just the derivative is just a little bit harder. But yeah, that's it. For the rest, 22 wants you to do 2 derivatives, and then, well, actually, they tell you what the same derivative is, and they ask you to do 1 more. Or they
Okay.
give you the original, and they tell you to find the second. So you do 1 derivative, and then you do it again
Yeah,
on the result. So
I'm
nothing
familiar
insane.
with that.
Okay, cool. At the very end, there's an interesting idea if you read this section. I'm sure you've read about this before. The derivative of a position function in physics is the velocity function. So this velocity function right here is actually the first derivative of position. Position being given a certain time, you'll be at a certain place or you've gone a certain distance. Velocity given a certain time, you have a certain velocity at that time. Derivative of velocity is acceleration, which is this first derivative of velocity, but technically the second derivative of position. So what you would do here is find 1 derivative for this guy and plug in 4. You already have velocity, just plug in 4 to get this one. It's really about it. Same thing here. You're given a velocity. If they ask about acceleration, well, you're going to need the first derivative. And then you plug in 5 into that result. It's just going to be a quotient. Does that make sense?
Okay. Yep.
Okay. But yeah, that's about it. I say we move on to chain rule unless you have some questions.
Nope. This is all familiar.
Alrighty.
As soon as I saw the actual formula for product and quotient rule, I was like, oh yeah, I know this.
That's good.
And I just want to let you know ahead of time because it's a school event. I will be out March 30th. They are sending me to Utah
For what?
for a conference.
For like work stuff or?
No, the school nominated me for the National Undergraduate Literary Conference. And I got accepted. So they're flying me out there.
Well, that sounds super fancy.
I'm excited.
Pretty cool. I don't know what it is, but it sounds interesting.
I didn't know what it is until they nominated me. I had to go in. I was like, hey, can I like meet with you guys? I don't know what this is. And they were like, sure. So I met with every single English professor we have.
Oh, wow. To hear it
They're like,
at St. Philip's or
yes.
damn. Hmm. What do you have to do at the conference? Just listen or give a speech?
Um, yeah, I have to read one of the stories I wrote.
Oh, okay. Hmm. Very cool.
Yeah, I'm excited. I just want to let you know, my chemistry class, Thursdays are lab day, and the 30th is Thursday. And apparently it's one of our most important labs.
It's the what?
So it's like, okay, whatever. I have a very important lab on that Thursday that I'm gonna have to miss. So I'm like, sorry, it's a school thing.
Oh man.
Yeah.
Hopefully they
It's like
are.
I told him ahead of time as soon as I could.
No, you're good. I'm sure you can just do homework on when you get back or before you leave or something.
I just want to make sure there were like no tests through 30th through 1st of April because I will be away and very busy apparently.
Okay. I have no idea if there is. I'll have to check, but
Okay.
if they
And I
just
can take it like before, but just let me know.
yeah, I mean, either way, whatever works for you, take it before or after.
Awesome.
It's not a big deal. Before might be better for you, but if you think you can catch up after, it's cool too. All right. So given a composite function, like you were talking about, let's say y equal to f of g of x, the derivative of y is equal to the derivative of the outside function times the derivative of the inside function. If it turns out to be multiple inner functions, then you just keep working your way out. So um, outer,
Like Russian nesting dolls, take off the outer layer.
yeah,
Okay,
exactly.
makes sense.
Which I don't, well, I don't know if you'll see any on the exam, but it'd be cool to practice like a 3 or 4 nested just to, once you can do those, you've completely grasped the idea.
Yeah, I can do these no problem. These were fun.
That's good. All right, let's do example 5. Find the derivative. Start writing better. Okay, so given y, keep using y, equal to 2 times 5 minus 7x to the 5th power. The derivative will be the derivative of the outside, which is a power function of 5th power, times the derivative of the inside. So derivative, so you bring down the 2, 5 times the 2, subtract 1, then multiply by the derivative of the inner function. So I'm going to show the steps there and put a quote on it. So I'm going to do a derivative on this guy. So then the outer one becomes 10 times 5 minus 7x to the 4th. And then do this derivative, so times. And that'll be what?
-7.
Yeah, it looks like -7 to me too. So at this point, multiply your numbers, you get -70 times 5 minus 7x to the 4th. So that's it. Giving a outer function of 5th power and an inner 5 minus 7x. Do the outside first, times you get rid of the inside. If there was one more inner function, you would do times that inner part. But that's it for example one.
Awesome.
Example two. You guys, you're cool on number one?
Yep.
Problem 7, find the derivative of, let's say y is equal to the square root of 7 minus 3x. So the outer function is a square root, right?
Yep.
So we can say that f is technically this, inner is technically this, right?
Yeah.
It would help to write this as a power instead of a root. So now do the derivative. Derivative will be, bring down the half, minus 1, now times the derivative of the inside. So far, so good?
Yes.
Okay. So it'll be 1/2 times 7 minus 3x to the negative half times, it's going to be minus 3, right?
Yep.
So at this point, a negative half means you should go to the bottom. So this would be a negative 3 over 2 times 7 minus 3x to the positive half. Do you remember bringing your power downward makes it positive, right?
Yes.
So then this is really 3 over 2 times the square root of 7 minus 3x. I think that's good enough. Minus, I'll put it in front. You could technically rationalize, but I feel like this is good enough, and I think the homework accepts this form.
Awesome.
But any steps that don't make sense?
Nope, they all make sense.
Okay. Now, towards the end, they're gonna start throwing like power rules and quotient rules that during the derivative you're gonna have a chain happen. So essentially, you could have like all 3 rules come out, or multiple at the same time. Let's do one of the product rules that will force a chain during the product. Okay. Example 5. Why are you blurry? Okay, let's say y is equal to x squared times the square root of 9 minus x squared. So the derivative will be a product rule, right? So let's say that f is this, I guess. But did you notice that the g is going to be a chain rule?
Yeah.
So you would have to rewrite this first. As a 1/2 power, so it's more obvious.
Yeah.
That the derivative will be. Do you see what this derivative would be?
Yeah, it would be 1/2, and then in parentheses, 9 minus x squared to the negative power of 1/2.
Yeah, and then times the chain rule.
Yes. So then times 9x. No, not 9. -2.
Yeah,
Not -2. Oh my god. Not -2x. Yep.
yeah. There we go. So once you simplify it, this would become what? 2.5 cancel.
Yeah, so negative. And then, yep.
Right?
Yeah.
And I'll do the hard one for you right there. Okay. So the derivative would be f prime g plus g prime f. It's just that the g prime is gross.
Don't be mean to it.
So y prime will be this guy times g plus g prime, which is this thing, this beautiful thing over here, times your f. Right?
Yes. Yep.
Okay. So this will become just 2x. This doesn't change much. First term. This guy will become minus x cubed over this. Right? So
Yep.
we're pretty much done. I mean, the calculus step ended here, but now we got to add these fractions. So LCD is this. So introduce it here.
Multiply both numerator and denominator by 2x.
By square root 9 minus x squared.
Okay.
Right?
Okay, this part I'm having some difficulty with.
Okay. And what's bothering you?
Because we have to. So, I don't know. Maybe if we move on to the next step, I'll get it.
So you see that this is over 1, right?
Yes.
So in order to add it, they need the same denominator. So I chose this one. Right?
Yeah. Okay. Yep.
So now they have the same. The only thing is I'm going to have to deal with this multiplication.
Yeah. Okay.
But you notice that this is the same, so the little square.
Yeah.
See?
Yes.
Okay, at this point, you can distribute the first part and then combine the fractions. So this will be 18x minus 2x cubed minus x cubed over. And just go ahead and put out the same denominator. So that gives us 18x minus 3x cubed over this, right?
Yep.
So that's the form that they, well, actually, they go one step further. They factor the negative in front and an x. And they write this. 6. That's the polished version.
Why did the 18 go to 6?
I don't know why I did that. I really wanted to pull out a 3 and I didn't.
Yeah, like I feel like it would have been like 3x on the
It should have
outside.
been, but they didn't do it. So let's go ahead and
That's
do that.
weird. Okay.
I think we should do it.
So is that on the homework?
This is more polished. They didn't pull out the 3 for some reason. Weird. But anyway, you can see how they can get kind of tedious.
Yeah.
It's like if they give you something with multiple parts, let me let it show you. Right, like this guy, as you're doing the quotient. Well, actually, this is a power rule, but it has an inner function. So when you do the inner, you end up with a quotient rule. Right?
Yeah.
And then this guy, you just did it. If you do a product rule in the middle of the product, you get a chain in here. This one is when you start the quotient, when you do G prime, you're going to get another chain. So it will be similar to this. And this one's just an uglier version of that.
So mean to these poor equations. They don't know why they were made this way.
I know. True. 16, only one is a slope. So you would take a derivative and plug in the x value. Just like we did on the first 3.1.
Okay.
The cosine derivative. We can do that real quick. I like to do a bunch of those. You start to see a pattern. So if y is equal to sine, let's say kx, and k is an element of the real numbers, y prime will be k times cosine of kx. This is kind of just a formula I made up just because it keeps happening. If it's cosine, similarly you'll have the same thing. Oops. It's the ugliest R ever. Okay.
It looked like a deformed M. It all comes back to M's, doesn't it?
I guess so. Something about m's.
Something about him.
So this is true for any k constant.
Okay.
And there's similarly for the secant, cosecant, tangent. You can do the same thing. So for example, if you have y equal to cosine of 3x, the derivative will be 3 times negative sine of 3x. That makes sense?
Yes.
So if you did it again, it'd be another 3. But yeah, that's pretty much it. One more formula, I guess. If y equals to e to the kx, and k is an element of the real numbers, then y prime is equal to k times e to the kx. So for example, if y is equal to e to the 2k, or 2x, y prime is 2 times e to the 2x.
It's probably the most normal thing that E's involved in.
Yeah, e is very special.
Freaks me out sometimes. E and ln. Like, I don't know what these numbers are.
Just that's just a special number, that's all. Like pi.
Yeah, but pi, I know down to like 4 decimals. I don't know what the first digit of E is.
It's 2.
Yeah, I was like, it's 2, right? But that's it.
I forget to, honestly. What is it?
That's what the calculator's for. I don't know why people were so insistent on teaching us, like a couple digits of pi, but like forget about E and ln.
Yeah, that's true. It's 2.718.
I was gonna say 2.87, so I guess closer than I thought I'd be, but not close enough to do any kind of calculations with it.
Yeah, I guess so. Better off using a 3, I guess.
Yeah.
I think pi is a little more magical because it comes from dealing with circles. So maybe it's easier to visualize as a
Oh,
kid or whatever.
I thought you were gonna start and saying like circles are naturally intriguing. I was kind of wondering where that was going.
No, it's just visual. As a kid, you know what circles are. So
Yeah.
I think learning about pi is not too ridiculous, but learning about E, I think requires a lot more knowledge. It's not as straightforward. I mean, relative to like elementary school, right? But anyway, do you have any questions about chain rule? Does that make sense?
Yeah, chain rule makes total sense.
Let's see. Here it is. Like I didn't see the derivation of E until I think one of the last classes in mathematics that I was taking. Let me see here. Oops. Here. When they take the limit of this function and they do all these sums, eventually it goes to E. So you have to understand limits, exponentials, or summations of factorials. So I mean, it's not everyday stuff. You know what I mean?
Oh my God, I remember factorials. Are we doing that in this class?
Yeah, no, I don't,
Oh,
not in
oh,
Cal 1. Cal 2 you will if you're going
oh
that far.
thank God. I hated factorial.
Do you
I
need
don't know what it.
calculus too?
No, I'm not even sure I needed this class.
I forget what your major is. Is it biology?
Biology.
I think you do. I would bet money you do. Unless you're not unless you're not getting a bachelor's or something. Yeah. But anyway. I guess we'll stop here then if you're